Welcome to the Human Activity Visualizer demo. We're going to do a walkthrough of our project and then do some demos to show you how to take the zip file on GitHub from scratch and get it up and running, log into the VM and all that good stuff. Right now, I am on the welcome screen, which you can access by going to this link up here, which is vcm-20389.vm.duke.edu, and that'll take you to the welcome screen. So first, let's go to the launch visualizer screen. And when you open this screen, there are no files selected, but off to the left, there is a file tree containing all of the data sets that we've uploaded. There's a demo, which has a file from the opportunity data set, a walking data set, the opportunity data set, which has activities like day-to-day activities, eating, relaxing, walking, and lastly is the user uploads. So when you're searching for a file, you can use the search bar up here, and any files that match will show up. You can also download files by right-clicking them and use this button to refresh the file list if you uploaded a file and it hasn't appeared yet. So let's use the demo file. Okay, so once the file loads, we have the model, and up in the top left corner, there's information about which file you're viewing, a button to close the file. You can reset the model, and that will put it in its neutral position. You can also change the views with this button, and you can play the animation in the bottom left-hand corner, and that will play the data set. If you go back to the hamburger icon to open up the menu, you can click on settings, and there are options to show the cards, and this is for the opportunity data set only, but they had tagged certain actions and objects. So when the participant did those actions or interacted with those objects, that shows up in these cards off to the right. You can also change the position to the bottom or hide them. And if you scroll, you can see how the different activities change, and he's like grabbing a cup, and all that is available in the cards. And then you can also change the timestamp down in the right-hand corner with these buttons here. So that's all for this screen. So one more side note, if you click on a data file, like try this one, and you copy the link, you can share the link and it'll open it up right to the data file that you're on previously. So that's just another tip. If you go to the About button in the bottom left-hand corner, this is where we have credits, some information about our website, and scrolling to the very bottom, there's a button to enter the development mode, which has pretty much the same stuff as the visualizer, but a few additional tabs, and those are accessed in the menu as well. There are sliders, and here you can control the quaternions for the different bones and see how changing the quaternions affects the model. This can be useful when you're trying to figure out which quaternion transformation is appropriate for a certain data set. And all of these abbreviations are available in the Getting Started page, which I'll show later. There's also an account tab, which is empty right now, but in the future, we can use it for making user accounts so they can only access the data files that they uploaded themselves and the ones that we uploaded. And lastly is the Labs tab, which is where we tested out a lot of our code And if you click on that, it'll show different, it's loading. It'll show different tests that we were running. So here we were trying to get the leg motion to work. And that's all for the labs. If you click on the top left button, the logo, that'll take us back to the visualization, or back to the home screen. And now I'll go over the buttons in the top tab. Here's the Getting Started page. Like I said, it has what the abbreviated bone names stand for and information for users to upload their own data sets. Next tab is Dataset Info, and it has links to the sources of the different data sets we used and a little bit of information about each of them. Then we have code documentation, which takes us to the table of contents for our documentation, and each of these links has information on the different components of our project. And finally, there is a contact us form, which users can use to send messages, and it'll send it directly to our emails. You can set it up so it sends messages to your emails as well. And if you click on this up here, it'll take us back to the welcome screen, and there's just a few more buttons. We have the Use Opportunity Data Set, which lets you access the opportunity data set directly, and you can pick a subject and a trial, click OK, and it will load that without you having to walk through the file tree. All right, and back to the welcome screen. Finally, we have the Upload Dataset button. So first step is you select a file, and you can enter a file name. And for each sensor, you have to input information about the sensor. So for this one, we're going to do right upper arm, and you can also choose what data type the sensor outputs. So this is quaternion, and the start column is 59. And you can click next. Okay, and then you'll come to a screen with a mini visualizer and the sliders. It has the same functions where you can choose the view, reset the model, and here you can input the transformation quaternion used for each bone. For this one, use this quaternion, and when those are set, you can hit submit, and it will upload your file to the VM and process it and get it ready to view. We'll see. Okay, and you can hit play, and it will play your data set. So that's all for our walkthrough, and now we're going to move on to the demos.
Hi everyone, I'd like to show you really quickly how you can start from an empty folder. So here we've got HWV test demo 2 is completely empty, and how you can pull all the information you'll need from Git, how you can get started running the server on your local machine and start developing this project. So the first thing you'll need to do is open up a command window and get into that directory. So we'll do that now. And then the first thing you need to do is download this using git pull. You could also download it as a zip file, but I'll just do git pull for now. Sorry, git clone. I don't know what I'm talking about. So you just copy the URL from GitHub and then append a .git on the end, and it will clone it. So now you can see you've got the HMV test folder here, and it's downloaded all the important source code files and the list of the packages that need to be installed. Now, hopefully at this time you've already had npm installed. If you don't have node.js installed, you need to go to the node.js website and install that. But I'm going to go ahead and assume you do have that installed, and that means we can run npm install. And what that does is it takes all the packages listed in package.json and package lock and installs those to your computer, because those aren't actually stored on GitHub, only the names are stored. So I'm going to go ahead and run that. One thing I'll note, well, this is, sorry, I need to change into the second directory. Okay, so this is going to take a while because it's going to be downloading several large packages, including Material UI. But while we do that, I'd like to show you one thing you can do with the server. And if you run it without downloading a file called sendemail.js, the server will still run. But if you would like all the additional functionality, you'll need to download that file from our server. And the reason that file is not on GitHub is only because it contains personal email addresses that might not be best if they were public. So I'm going to show you how to download that file from the server right now, while this is loading. And so I'm currently in the site where the folder where the site is stored on our server. And if you look in the directory, you can see this file sendemail.js. And in order to copy this to my local machine, I'm going to need to first move it to my home directory. So I'll make a copy of it. I'll copy sendemail.js to my home directory, which is just this tilde with a slash. So now if I go to my home directory, you can see I have sendemail.js here. And so now I'm done on the virtual machine side. I just need this one file, so I can exit out this. And what I would like to do now is copy that file from the server. And you can do this using several GUI utilities. I think Sam knows a few of these, but I'm just going to do it from the command line right now. And so this is the current project directory. I'm going to switch back into the demo directory. So now we're in the demos project directory, which, as I showed you before, was empty, and now it has our files downloaded from Git, except for send email, which was not on Git. And so what I need to do is use secure copy from our virtual machine. So it'll be my email address at vcm-2389 at .em.duke.edu, and the file I need is sendemail.js. I'm going to be copying it to the current directory, which I just indicate with a dot. And so after I run that, you can see sendemail.js just appeared right here. And that was great timing, because now our node packages have finished installing, and we should be able to run node server. Actually, sorry, we can run node server, but let's also first build the website, because the final production site is not actually stored on GitHub either. If I do npm run build, this will take a minute as well. You can see it just added this build directory right here. It's currently adding all the stuff from our website, taking this code, which is in the source directory, and compressing it so that it's a little more difficult to read, but also much smaller file sizes. And so once this finishes, excuse me, once this finishes, we'll be able to run node server. And actually, we can probably run that now. Let's see. Okay, so this is an error which I probably should have looked into beforehand, but in order to use the authentication for email address, you'll need to download a credentials.json file, which I may be able to now. Let me check. Okay. So let's see what we got here. So I can go to this credentials tab, and I'm using this one credential. I'm only signing in as myself, but you can see here it says HMB server Gmail. And so I just need to download this file and save it as credentials.json. So we'll do save as, and we'll go to the demo here and run it and say this as credentials.json. And so now, okay, our website's done building, and so now if I stop the server and start it again, you don't receive that error that the credentials.json file is missing. And so if we go to our local host right now, you should see the website up and running. And here we go. We started from scratch, and we've got the website with everything Sophie showed you. Obviously, the file structure is a little different because I don't have all the files on my machine that are on the server. And so you'll just have this demo file here because that one was stored on GitHub. So one additional thing I'd like to show before we close out this section, what I was mentioning with the API credentials, that's related to the contact us form. And so when I enter my message here and I attempt to send this message, so I'll type this is a test message. Attempt to send this message, you'll see in this command window, not this one, but this other one, it's going to ask for me to find some credentials online because I haven't authenticated my computer yet with Gmail. So when I send this message, it will say, well, it's warning me that I didn't enter an email address, which is okay for now. But it actually doesn't give us any feedback that we've sent the message, and that's because it actually hasn't sent the message yet. And so I have to first go to here and let's see. Hit the wrong key code. I was trying to copy something. I need this code right here. So I'll copy that. It's going to ask me to sign in. I'll sign in as Human Model Visualizer. Just click continue here and allow it to do all of these things. And once you click continue, you'll get a code that you can copy and paste. And we probably have edited this out of this video, so you won't be able to see anything right here. And so let's see here. So if I paste that here, I think it should work. Well, I might have to stop it and start it again. I accidentally hit a key combination that stopped the server, so I'll just try to send this email again. So now it's asking for the code. I'll paste it, then press enter. And now you can see that our message has been sent, and the token has been saved on our local directory, and so it's not going to ask us to do this again. And so if you're restarting the server somehow and you manage to try to start from scratch, you would need to do this token authentication. But you can visit that link on any browser. It doesn't have to be on the host machine. So if you're doing this over SSH, you can do the same type of thing just as you would have if I was loading on my local machine. And I think that is about all as far as the local setup goes. We've gone from an empty folder to a complete working website. The only thing I haven't shown on this video, which you might be interested in, instead of using node server, which stops as soon as I press Control-C, which kills the process, you might be interested in using PM2, which is a process manager. And how you can install that is just npm install and do -- I think it's global and PM2. And then it'll go through and install this. And then instead of doing node server, you can just run the command pm2 start server.js. And if this finishes quickly enough, I'll show you how it works. Okay, great. So obviously you can see right now, server is not running. You've got this loading icon because I just stopped the server. But if I run pm2 start server.js, let's see what we got here. And now the server is back up and running. As you can see, I can close this command window and the server will keep on running because that process manager runs in the background. So that's one thing you can do. Other alternatives you have, if you'd like to test out the site, you can just run npm start. And that will take a few seconds to load, but it will start a development version of the site. And when you edit your code, those development changes will actually be shown live to you on the server. And if you take a closer look at the proxy settings, some of the file requests do run through the original server, which is just on localhost port 443 for HTTPS. As you can see, I don't have the credentials for HTTPS downloaded, but they do. This does work as long as you use HTTPS. And our localhost 3000 server is going to make requests through this localhost port 443, which means if you're going to be running localhost 3000, you do need to also probably be running the regular server through node server or PM2 start server. I was hoping this would show up before the end of the video, but it will take a few minutes to load the development site on occasion. And there we have it. Our Human Model Visualizer website is running currently in both development mode and production mode. Just some terminology you may want to be aware of. This is the React dev mode. We occasionally refer to something on the website which I'll refer to as /dev mode, which basically means when I click this button, it appends this /dev right here, and you just end up with a few additional options on the left over here. So there you go. You've got your production mode, React development mode, and you've got the server running with all send email functionality.
Hi, okay, so what we're going to show off is, suppose I have like a new data set that I want to mess around with and potentially put on the website, right? Because it's, some human activity data set that has IMUs on parts of the body that we can show visually. The question is, what do I do in order to even get started with it? So what do we need to have to start out is we need to know what kind of data it is. So for example, in the opportunity data set, ignore this just complete wall of numbers. I swear this is just an opportunity data set file, which is subject one's drill file, which we're going to do the run, or we're going to show off our demo of parsing a file using this, right? And so I happen to know that somewhere in here it contains quaternion data, which is lucky because it's the exact same kind of format that we show on the website. And so that's what we're trying to translate into. So continuing on, meshing just straight into this. We need the raw data. I have the raw data right here. It looks very raw. We need some kind of documentation about what the data actually represents, right? And we're going to need some level of detail. And so what I'm looking for specifically is, what do each of these columns mean? What kind of activity are we looking for on the person? And yeah, what kind of data is it? So for example, we've seen accelerometer, gyro, magnet data. We've seen Euler angles. You could see rotation matrices if somebody wanted to turn on that output mode on like some kind of Xsense IMU. So keep a note of that. And you'll want, we'll have a guide on this on the documentation on how to make a new handler, which is just a Python script to take a piece of data, or yeah, take columns of data and translate it into quaternions, which are our end goal. And you'll want the appropriate handler right here in data type handlers. And right now we have handlers for accelerometer, gyromagnet, and delta quaternions and Euler angles for trying this out, which is good enough for this data set, right? Okay, so we have that all together. And now we're going to actually use a script. So I have a script called use data type handler multi. Sorry, this is in the HMV Scratchpad repo, which is just sort of a sister to the HMV test repo. And it's for hosting code that's useful for us that, well, it's for hosting just sort of any Scratch work, any journals, and any scripts that are useful to us but don't need to be on the website. And so you want to make sure you have this cloned down, and on it is the script in the folder called data playground. Okay, so it's called use data type handler multi, and it's called that because it uses data type handlers to parse data out of a raw input file, and it uses multiple of them. So I have a terminal open in that folder, and let's just get started with it. So clear the screen, and I'm already in the appropriate folder to use it. So Python use data type handler multi, and let's just take a look at what kind of arguments it has. Quite a few, but we have a target file, we have a data type, we have column indices inside the file because we expect data arranged so that like increasing rows is increasing time, right? And columns are data type, right? And then where do we want to store the output? And so when I put all these together, where do I get this data? Well, in the UCI repository for the opportunity data set, we have this handy file, which tells us the column indices of, or takes every column index and tells us what it represents. So something I'm really interested in is quaternion 1, quaternion 2, blah, blah, blah. And based on a manual for the type of IMU that was used for opportunity data set, we know that this is WXYZ for the quaternion. And so this is all information that we need to have gathered through research, right? And now using that, I know that the command is going to look like, let's see if I have it available right now. All right, I have it right here. The command is going to look like this. That's quite a mouthful, right? But here's where our source file is, right? And we can scroll through it on our file explorer here. It's right here in this opportunity raw folder. We know that the data type is quaternion. We know that column 46 is the start of the first sensor. And we know that it's 13 columns. This is stride length, right? So number of columns between sensors, quaternion data, right? And we know that there are 5 sensors, 2 on each arm, and then 1 for the back. And then we just choose some place to store it. And so I've just stored it in this other folder here. And there's this optional argument that I'm using here. And what it means is that we take this factor of 1,000, we divide every incoming piece of data by it. Why do we use this? Well, if you'll notice, just look at the data set. Let's just pick a random number, say over here. It doesn't have a decimal point. Why is that? Because everything is multiplied by 1,000. And that's once again specified in this handy file that's been given to us with the column indices, which I happen to have closed at this point. Okay, and now let's run that. And it printed out a bunch of stuff, and then it produces this output file, which is a .dat. And I've named it a .dat by specifying the output file name. So you can have whatever format you want, or sorry, whatever name you want. And so first thing we do is inspect a file to see if it makes any sense, right? Does it have an accurate number of lines? It seems like to have a reasonable number of lines, which is on the order of 900, which makes sense because it's about a 30th of a second sample rate, and we have 30 seconds with this one. Are these all less than 1? Do we see that the magnitude of each of these is adding up to 1 approximately? And we can see that all of that checks out, so that's really promising, right? But we can't just take it at face value necessarily. I don't trust it at all, especially if I'm trying a new data type handler. And so there's a couple of ways we can verify that this makes sense. One way is using another Python script in here that uses Matplotlib's 3D graphing software, and that's called graph animate transform.py. And that one has its own list of arguments, right? Especially if it runs. This is a Python script. I don't know why it's hanging up. There we go. Okay. So it just has one positional argument, which is what file we want to visualize. And that's actually good enough for us. So I have it on my clipboard right now, what command we want to use. And it looks like this. And so you can see we're just using the same file as before. And I've used an offset, right? And an important question here is which column refers to which part of the data set. And it's whatever the order was in the original data set, right? So for example, based on the column indices, let's see if I have the column index open again. There we go. So we can see just by scrolling through that we start with the back sensor, and then we go to right upper arm, right lower arm, right forearm, and move on to the left arm. And so if we have an offset of 0, then that's the first set of quaternions, the first 4 pieces of data, and that's the back. And the next up is the next 4 pieces of data, which is the right upper arm. And the right upper arm moves in this, right? We expect it to clap. I suppose I could do some spoilers and show off what is the final goal for what this data is going to look like. And it's already hosted here. So if we go to opportunity dataset S1 drill, we happen to know that the first thing they do is clap. So that's what we're looking for. So let's see if that's what we get. And this is just a quick Python graph of it. Forward is the green arrow, so you're going to want to pay attention to that. And you can see that the arm is coming around all the way back and then hitting something, right? So that's really promising. You know, not convincing, but promising. Or no, not definitive, but promising. Okay, next thing we can do with this piece of data. Go to the tinkering tool, right? So the root of the website /tinker. There's no button to get to this exactly because it's not necessarily very useful for clients. It starts out with the every orientation in default position, right? So everything's pointing up except for this hips node right here. And so we'll just choose the file to submit into it. And it's going to be data samples / let's see if I remember where it is, opportunity. And it's going to be in our process folder. So I've selected it. And now we just need to go generally in the order of downstream in terms of what joints affect what other joints, right? So let's use the back sensor to manipulate the hips. And we can see just by adding some quaternions here, and we pick an axis and then how much angle to rotate around it, right? And this moves the entire model. So we probably want that pointing generally upward, right? So point this generally upward, and another one is the back. It also follows the exact same piece of data because we'll have the torso controlled all by the same thing, and we'll angle this up, okay? And now we trust that a little bit more. And one more thing, this is downstream the hip, so we're going to end the back. So we're going to add a quaternion to that to see if we can get it to a more reasonable position. This is where we put what data column we should read in order to get the orientation of this. So this is column 4, just like on the graph program that we showed earlier. And let's just angle this about the wrist so that it's in a more reasonable palm position. And let's just go forward with this. We can see that it's going back and then forward, and then it's bumping into something. And so we would go through that entire process in order to get a reasonable looking movement for every single limb, right? And then eventually we would click this file this right here to download a metadata file in the required format. And once we do that, we have everything we need. So now we downloaded this metadata file from the Tinker tool, and I didn't do all the necessary quaternion transformations for every limb in the demo we gave. So I borrowed a file that we're using elsewhere. And there's 2 important things about this file once you download it that you may want to change. The first is the name. So I've given this one a slightly descriptive name. Let's call it demo instead of test. In order to show, it's the S1 drill file from the opportunity data set. And I've also added this extra JSON field that doesn't show up straight from the download from the website, which is global transform quaternion. And that gets used in the program to pre-multiply every transformation that takes place, so every data quaternion. All of these are post-multiplications, which means that they can change the orientation of the limb, but they cannot change the direction of the overall motion. So that, if you have your arm moving counterclockwise or clockwise around yourself, there's no way you can apply one of these quaternions to turn it into the opposite direction of motion, but this one changes the coordinate system of the quaternions essentially, right? And that's going to be important for this example, opportunity data set, because it uses a different coordinate system compared to 3.js, which is our software or our library for rendering our scene, right? And we know that based on looking at the manual for the XSense IMU, which is used in quite a lot of motion data sets. Okay, so we added those to the metadata file, and it's already called metadata.json, or we need it to be called metadata.json. And we have a file in anywhere in this file's subdirectory of HMV test. I put it in user uploads for now, so that it's, stuffed in there with everything else that's just sort of scratch work. And I've also moved this quaternion file that we produced using use quaternion handler. And we just need to rename it because the program determines whether a file is, or whether a folder is valid and what specific files to use based on name. So we'll call this quaternion data.dat. You know, all the other data sets have metadata.json and quaternion data.dat. Okay, and now that we have these together, and you know they point to the appropriate columns and it's all configured, we should be able to go onto the website, which I'm currently hosting locally, because this is my local copy of HMV test and we haven't uploaded these yet, and go to the home page and launch Visualizer. And let's see if they're visible immediately. And we're looking for that display name, right? And it's not visible immediately because this is a server-side change, so it's not going to immediately reflect. So we need to refresh file list. That's currently not running in my current branch, apparently. So we're just going to do the old-fashioned restart the server using Control-C, and then node server in the HMV test directory. Then we can launch the visualizer and we'll do a full rescan. And we can go to the user uploads folder, and we see S1 drill quaternion handler test. And if we click it, it will contact the server, load the file, and then if we play through, we can see the guy clapping. And that's exactly what it's supposed to look like, as the reference in the opportunity data set shows, which we're going to have to pull up the reference from the VCM site. So let's do that really quick. And here's the clapping. Okay, so that's how we run it through, and take just raw data and turn it into something that we can use in the actual program, and then upload onto the server host so that it can deliver it to random people on the internet. Hope this helps. One more thing I want to mention is that you may have to do some other processing in order to group the files into the same sort of one file corresponds to one trial layout that we see in the opportunity data set. So, for example, there's the Luo et al. Gate data set, right? Human gate. And if we open up my local download of that over here, then we see that it has a bunch of CSV files, right? So that's the first thing, they're separated by commas. And there's 5 of them. 1, 2, 3, 4, 5. That's 6. There's 6 of them that correspond to one trial. And they're separated, this is based on documentation on the paper they released. They're separated out based upon these last 2 digits, letters of the file name, and it represents which sensor. So in opportunity, we would see these files all placed next to each other so that we have, you know, 100 and something rows. And that's what we want in order to process them with used data type handler multi. So I've come up with a script called append files horizontally that we can just open up a terminal in this location and append files horizontally. Let me make sure I'm in the correct directory. So I've got to get into the data playground directory. That's where we are. And then I can run Python append files horizontally, right? And by horizontal appending, I mean just place them next to each other, essentially, on a piece of paper and make them one file, right? So if we do the -h flag on it right here in the bottom terminal, then we see that it just takes a target directory and an output file. And so if I were to specify the directory, you know, data samples / Luo et al. Gate / gate data raw / subject 1 surface 1, then it would take all of these files, assuming that this didn't exist yet. This is the output. It would take all of these files as comma separated, and wherever I specify the output file, it would put just all of the columns together. And then we can run data type handler multi, where the stride length is the number of columns in one of these files, which I think is 30. And the first column that we look at is, well, we could do it via accelerometer gyromagnet, but I trust the Euler angle handler more. So we have roll, pitch, and yaw over here, and just by counting, this is the 21st column into the file. So we'd start at column 21, have a stride of 30, and say that there are 6 sensors, and run it on this appended file.txt. Other than that, it would be pretty much the same process. Hi, okay, so in this part of it, we're going to show off how do I do server maintenance and just generally check and modify things on the actual production server that is running on a Duke VM. And it might be in a different VM if you're working with it, but this sort of generalizes to, yeah, as long as it's on some remotely accessible system that is hosting this web page, then it should be applicable. And the tasks in specific, are we going to do just general monitoring on the server, go over sort of like what is the file structure on the server, and how do I move data files onto the server, and how do I mess with code. So some things, or one thing that's going to be useful is you're going to want some SSH client. A couple of options are, if you're on Windows, MobaXterm. And another good option is Visual Studio Code has a plugin that allows you to remotely access SSH targets. So I have that configured right now. And so if I open SSH in new window, for example, with this particular accessing the home drive of the VM, and this is just one method, and I'll show off another method really soon, but this will help us take a look at the file structure. So it's going to take a while to connect, and it's going to ask me for a password, and this is just the password. Assuming you have permission to the server through your net ID, this is just my Duke password. And now you can see the home directory on the server, and it has the following. This is the directory that I, as a user, am specifically authorized to mess with. So this is the easiest to one where I can, yeah, change things around and make edits. And then this webs folder at present is where we actually host the web server itself. And those are both going to be relevant. These are both in the greater home directory. And so this has the exact same structure, almost the exact same structure, plus a couple things of the HMV test repo. So now I'm going to switch to just command line so that we, yeah, don't have to rely, or so we know what commands we're going to need for the Visual Studio plugin if you end up using that. And so you just don't need that Visual Studio plugin in general. So I'm opening up MobaXterm, which is my SSH client, and I'll start a local terminal, and then I'll do SSH, and then STT13, which is my net ID, at VM2389 .vm.duke.edu. Sorry, VCM over here. Okay, and that's, you know, this is going to be, this part right here is going to be whatever you use to access the server, you know, URL-wise, unless we've covered up by now. It'll ask you for a password most likely, and I just cached my password in MobaXterm like a fool. And it puts me straight in my local user directory, right? So here I am, /home/STT13. And then I have full access to go over to webs and look around in it. And if I go to HMV test, you know, here's all the files. And we're using Process Manager 2, like Jonathan mentioned, to actually run the server. And so if I do PM2 monit, which means monitor, right, we can see that the process is running, except sometimes I don't have, or my process list doesn't include server, and the reason is not because the server isn't running, so don't panic. It's because I've logged in as STT13, right, the user, and I need to use root permission. And a couple things I can do is, one, I can switch to being the root user, or two, I can just use sudo to run this. And I'm going to take the latter option because we don't need to switch to root. So now I'll just do sudo pm2 monit. So basic Linux permission stuff. And now we can see the server is running, and here's the logs. It's not doing anything at the moment. It would print something, for example, if we tried to submit a file to the server, or I suppose if we restarted it, right? And you can see, various statistics about it. And the main thing is the fact that it's running here and what are its logs. And if I want to look at the logs specifically, because it's hard for me to like scroll through the logs on that monitor window, I can just type in logs, and they'll give me a live stream of the logs. And so you can see that recently, it looks like it's printing out some kind of JSON, which probably means that somebody submitted a file through the upload form recently that included write upper arm and, yeah, just a write upper arm bug. Okay, so there we have that. And PM2 also lets us start and stop programs. So for example, if I change something server side, then like something in server.js, it won't immediately update like with, React development mode. So I can do sudo pm2 restart server.js, and I have to be in the directory with server.js because this is an actual like program I'm running. And so that just restarts the program. And of course I could also stop and start it. So I believe the syntax is we can just stop it. Don't do this. And especially don't do this when the app is in use. Restarting is fine, but yeah, try not to do it when somebody's in the middle of, submitting a file or something, because that will undo all of their work, right? And now I can just start it back up. And now if I go back to my monitoring, here it is running with any updates I've applied. Okay, next thing, how do I modify the code? Well, I happen to be using an SSH client that has some built-in text editors. So that gives me a couple of tools, right? So I have this folder in my local directory that I've created called HMV test mirror. We also Git on this. So theoretically, you could pull it onto your own user. You could pull the repo and then make changes, because there's a webhook configured with Git and with our server, so that whenever you push to the current branch that the server's on, which right now we're on branch master, which I can check Git status, you can see that we're on branch master. So whenever master gets updated, if things are working properly, then the server will automatically download any updates. So I have this folder here in this tiny little file explorer that I have in my SSH client. And it just mirrors the structure of the server, right? So if we go to source, I have the server side folder just like on the repo. And for example, I can go into this Python programs and we have multi-sensor fuser object. I can double click on it and open it up here in my client. And this would work with the VS Code plugin as well. And I could remove the word the because I hate grammar, and then save it just fine. And I'll be prompted to do a secure file transfer, and I can click yes, and that'll change on its own. But if I do the same thing in the webs directory, it'll say I can't do that because I'm not, a root user. So what do? Well, I can just cd all the way back. Let me get it right this time. I got to go one step back. Okay, and here we have the object that I just modified. And yeah, it exists and everything. It has a bunch of code, and I removed the word the, which is, yeah, not a change I recommend doing live server maintenance for. But this helps us show things off, right? So now I can do copy, just the normal Linux command, right? And then name the program, so multi-sensor fuser object.py. And then where do we have to go? We have to go several directories back, right? So 4 directories back, 1, 2, 3, 4, 5, because we need to get out of my local user directory. And then we can go into webs/server or /source/server side, and you don't need to memorize these paths, right? We have this tool over here to go between them, right? So you can see I had to go back 5 times. And then web's HMV test, server side, or source, sorry. I'm gonna mess around with this thing. Server side, Python programs. This gets very deeply nested. And here it is. So same name as before. Multi-sensor user object.py, and it actually auto-completed for me. Okay, and if we just do this command, permission denied. Why? Because this requires root access. So sudo it, and it works. Okay, and now if we open up this file here, it'll take a while to transfer it over to my system. Okay, so we finished with this change, and we copied the file over. And you can see that we've removed the word "the" successfully. Though I do want to kind of add it back later, so let's make a note of that. And that's how we do live code changes. That's one way. And you could probably get this into a bash script so that you could take your entire mirrored version of HMV test and copy it over to the part of the server using sudo permission with a password. Okay, and last thing to show off is, suppose I have a file locally that I want to put onto here. I'm not going to copy paste it through this because that's just bad. And I don't want to use Git for it because Git is not a file transfer software. It is for version control. So I can use a secure file transfer thing. And one such example, FileZilla, that's your standard, file transfer protocol program. And it's the same deal as before. So the host is VCM 20389, might be different for you. Username, definitely going to be different. And we can click connect to it. Yes, I trust it. And here we are. And we can look through our home directory, and we can't transfer to webs because we don't have permission, but I can transfer to my own user. And so if I have a file for, this one, for example, I could go to, HMV test mirror files, user uploads, and move this over, right? Just like that. And now I have it there, and it should be finished by now. Yeah, it was a small file. And so now if I go all the way to my own user directory, and then into the files subfolder, then here it is. And that's just one quick way to transfer files over. And from there, I would probably use the same copying procedure. Last thing I want to mention is that we also have on the command line, we have the SCP command to secure the file copy. And that one was showed off by Jonathan in his part of the guide. Okay, I think that's everything. Hope that helps you enough to get things done on the server without messing it up. And yeah, if stuff does mess up, fix it.
So I wanted to quickly show what Sam mentioned as far as the server automatically pulling from Git. It's actually quite simple. If you just check the settings on this repository, you can see this tab called Webhooks. And anytime there's a push event, you can see it's going to make a request to this URL. And I have to confirm my password apparently. But you can see it's going to make a request to /API/pull. And this is only going to happen for the push event. And if we go to the server and we look at it right now, what you'll see is that pull. So this is the actual function that's going to be called when our pull request goes through. It's going to execute git pull, copy the results to git log, also run npm run build and copy the results of that to build.log. But the actual thing that's going to be called is when we receive a post request to API/pull. That's not going to be called if you do just a GET request. So if you type /API/pull, you'll get a message on your screen that says post request expected. So only the post request will trigger the server update.